Hi, good afternoon, my mentor Tyler and my educational technology classmates. Today, I'm going to share my second milestone, see what I have did, and collecting some feedbacks. And I made a slide, and I'm going to do live demo. So let me share my screen. In my first milestone, I presented the interaction design for a large language model-based learning system that support productive struggle instead of giving students immediate answers. At that point, the work consists of prompt templates, scenario definitions, and an evaluation checklist, not a fully functioning application. From this milestone, I turned that design into a working browser-based prototype called SocraticPath. I briefly explained the design, demonstrated a complete tutoring interaction, and then showed the preliminary verification work and the feedback I still need. The project's central goal has not changed. Standard AI assistants are often optimized to produce a complete answer quickly. That is useful in many settings, but it can undermine learning when students need to practice selecting operations, noticing errors, and explaining why a method works. SocraticPath treats a system as a sequence of pedagogical decisions. It first asks a diagnostic or Socratic question, then adds more explicit support only when the learner remains stuck. When the student reaches the correct result, the system does not simply end the session. It asks for a self-explanation so the learner reconnects the answer to the reasoning. This slide shows the concrete change since milestone 1. The first milestone defines the interaction. It defines the interaction components, but no code had been implemented. And the current milestone includes a functioning local web application. It has a student-facing chat, three pre-authorized linear equation scenarios, a misconception library, a five-level escalation state machine, and an instructor-facing trace that explains the system's latest decision. The remaining final project work is evaluation and refinement rather than building a broad platform. I plan to expand the script interaction metrics, adjust the policy based on feedback, and package the prototype with complete documentation. The main architectural decision is to separate pedagogical control from language generation. A student message is classified as an attempt, a hint request, a direct answer request, or later a self-explanation. The system also checks for no misconceptions. The policy engine then selects the authorized support level. The model does not decide whether it may reveal the answer. A final guard checks for premature disclosure and fallback to the policy-safe response when necessary. The instructor trace exposes this entire decision path. The policy have five visible levels. The first successful attempt remains at the Socratic question level because one wrong answer should produce diagnosis rather than an immediate hint. Continued attempts move through conceptual and strategic support. A partial work step is used after a sustained impasse, and the full explanation is reserved for the final level. A student can request a hint, which advances the level by one. A direct request for the answer also produces more support. but it is kept below the worked solution level so that just tell me can't bypass the learning interaction. At the same time, at the same time, the system does not withhold forever. Repeated successful effort eventually authorizes a work explanation. And now let's switch to the live demo. You can see this is a web application I made for my prototype, and here it has three sections. First is the three demos I have, and here is the chat box, and here actually is the coaching trees instructor view. And this is a linear equation problem, and we can here first type, let's try s equal to 5. See, actually, it will give you, obviously, this answer is wrong because the answer is 7, and we can see it will point out to you where you can think wrong, and then let's try the second scenario, like it's just tell me the answer. Let's see what it will show. See, actually, rather than revealing the solution, the system redirects the request and raises support to a conceptual hint. Yeah, I will choose that I need a hint. You can see it will actually give you out a path to see how to consider it. And then let's enter s equal to 7. The system confirms that the result satisfies the equation, but moves into the self-explanation state instead of ending. Yeah, so that basically is my demo. And so this one, we can see it basically fulfills what my design requirement. And then let's go back to the slide. Then, for the testing purpose, I have also added 9 automated and end-to-end tests. They verify that known errors trigger targeted feedback. Repeated attempts escalate monotonically. Direct answer requests are redirected. Correct answers move into self-explanation, and premature model-generated answers are blocked. An integration test starts the local server, load the interface, create a tutoring session, and complete a turn. These results demonstrate technical and behavior consistency. They do not demonstrate improved learning outcomes, and I do not want to overstate them. For the final project, the evaluation will remain a scenario-based formative evaluation unless I can gather limited informal user feedback. The goal is to show that the policy behave as designed across representative interaction paths. The feedback I need now is less about adding features and more about the pedagogical judgment encoded in the policy. First, is 5-level escalation too rigid, or is that transparency useful for a proof of concept? Second, does the instructor trace expose the right information for evaluating the system decision? And the last one is, should the work explanation be triggered mainly by attempt count, by explicit hint request, or by a combination of both? Yeah. Okay. Thank you. Basically, this is my progress snapshot for Milestone 2, and thanks for watching. Have a good day.